A 75 milliliter solution of HCl with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity of calcium hydroxide, which is CaOH2. What was the concentration of HCl in the original solution? So we know that the volume of HCl, but we do not know the concentration. And we know that it's titrated with a volume of 27.3 milliliters of a 0.157 molarity of calcium hydroxide. So we know that both of these are strong electrolytes, so that means that they will both dissociate into ions completely. So from that, we can do the mineral picture, which I drew up here. So for this one, there are 2 hydroxide ions for every 1 calcium ion. And over here, it's a 1-to-1 ratio of H and Cl ions. So we have the volume and concentration for calcium hydroxide, so we can use that to find moles. So we're going to change 27.3 milliliters into 0.0273 liters so that we can calculate moles since volume is always in liters. So whenever we calculate that out, we get 0.00042861 moles of calcium hydroxide. And that tells us how many moles of calcium hydroxide reacted. So now from there, we are trying to figure out the concentration of the original HCl solution. And in order to do that, we will use the equation of 0.07 liters times concentration equals how many moles of HCl. So we had to change the milliliters of HCl to liters because we always use liters. So there's the equation right here for moles of HCl. And so now we have to find the moles of HCl, and to do that we will use the moles of calcium hydroxide that reacted with it. And these two are connected by the ratio, which is found in the balanced equation up here. So there are 2 moles of HCl per 1 mole of CaOH2. So to get from this equation to this equation, we will use this ratio right here. So if we write that all out, we do the moles, which is liters times concentration of HCl, equals the moles of calcium hydroxide, which is liters times concentration, times the mole ratio from the balanced equation. And whenever we figure that out, we get a concentration of 0.114296 of HCl. So that's our answer right here for the problem. And common mistakes people do when trying to solve this problem is that they use the M1V1 equals M2V2 equation. And if we use that, we would have not got the right answer to this problem. So yeah.